Hello, my name is Steven. Welcome to Hyfindr Tech Talks, where we aim to understand the technology that makes the hydrogen economy work. Today, we are going to talk about leak testing bipolar plates. Now, this is a very specialized topic, but I'm very happy that for this we were able to get an expert who works at Makeas, and they have been specializing themselves in this over several years. He himself has piled up, I think, an engineering degree. He has an apprenticeship in this area and business degrees on top of that. He's leading all the efforts that Wortmann and Makeas are driving in this field. I'm very pleased to welcome Daniel Schönbohn.
Hi, Steve. Hi, everybody. Nice to meet you. Nice to be here.
Hello, Daniel. Thank you for coming all the way to talk to us about this. And well, just to kick things off, what is leak testing for bipolar plates?
Yeah, leak testing is part of the quality assurance, and you want to test if your bipolar plate after a welding process is leak tight. It's tight, it's good.
Okay, so if it doesn't have anything, well, that's pretty obvious.
Yes.
and who uses this? Who does this?
Usually the fuel cell manufacturer, the fuel cell, or the companies who build bipolar plates for the fuel cells, for the electrolyzers, of course, also. Both need fuel cell bipolar plates. Yeah. So these are the main customers in this case.
Okay, so we are essentially very close to, let me say, what can form many parts of the hydrogen industry, electrolyzers, fuel cells, and so on.
Both sides, using and producing. Yeah. These are necessary parts of the process, of the production process.
Okay. So Daniel, can you please take us a little bit deeper into the process? How does this work? I mean, you know, it sounds so high up there, like leaked, but take us through.
Yeah, generally speaking, it's very simple, but the devil is in the detail, as you know. And I have some pictures with me.
Yes.
And
okay, we have them here.
Maybe we can show them. And yeah. So this is our, I would call it a standard machine. So we are a machine builder in general, and we are focusing on leak testing. So this is our machine which we developed especially for leak testing bipolar plates. Yeah? Okay. Double station machine, and can test 4 bipolar plates.
Double station means one station here, one station there.
That's correct. Yeah.
Okay,
so that's we have.
So is it a human being that will be standing in front?
In this case, there's a human being. Loading the bipolar plates and unloading the bipolar plates.
Yeah. Okay.
But the process itself, it's running automatically.
Okay. All right. Okay.
And if we go, the next one.
Yes.
Yeah. Now we can see it more in detail. So we have in each station, which are independent. Yeah. You can run both sides fully independently. You can test the plates here. You bring the plates in here, and this and this. You have always 2 plates in the machine, and then it's closing, and the process starts. Yeah. Then you can see not so much anymore.
Okay. So that stamp goes down, and then that works.
Correct,
okay. All right.
And then the leak testing itself starts.
So of course we are curious to see what is happening inside there.
Yeah, that's true. But unfortunately, from the outside, it's not possible to see it. So we can just, this is another view inside. See the other side on the top here. Yeah. But in general, it looks like that, more or less.
So this is essentially what we saw in the photo, like the top view of one of those.
Yeah, that would be, for example, this
like,
side here.
So we're basically seeing this. Yeah. Okay.
Correct.
So
that's correct. Basically
now
seeing this.
We're looking at the top here.
So we have outside the ceiling of the chamber. We call it the vacuum chamber because
this is all
the gray
sealed.
one. Yeah.
Yeah. Okay.
So we are working with helium.
Yeah.
We are using a tracer gas like helium to detect leaks. Yeah? So we have a mass spectrometer installed, which is detecting the helium atoms coming out. Yeah?
Yes.
And therefore we have a vacuum chamber because we want to detect very small leaks.
Yes.
That is only possible with this tracer gas like helium and in a vacuum chamber.
Yes.
Yeah. So that's how it works. Yeah. Just to explain it a little bit more in detail. So we put in the part.
You put in the part. Yeah.
Either a human being, a worker in front, or a robot.
Yeah.
Both is possible. We already built both of them.
Okay.
Put them in. So then the machine is closing.
Yes.
So then we have the sealings on both sides of the tool. Yeah? So we seal the 3 circuits. Yeah. We have the sealing outside. We have the sealing for the port of the sealing for the port of the cooling. Yes. And we seal the complete area for the anode and cathode side. Okay. Oxygen, hydrogen side.
So you have a sealing on the outside here. You have a sealing for this channel basically, and this channel, and this channel.
And then also around, to have the fold, the flow field closed.
Yes, closed. Okay.
So then we evacuate everything. Yeah. So we put, you can see 0 bar everywhere. So we need a very low, very deep high vacuum in order to find these small leaks.
So just to understand again, why we are seeing two plates here is because in the machine there are always two plates being tested at the same time.
That's a question of cycle time.
Okay, so exactly, you double your cycle time.
Yes, that's correct. So you can also test one.
For the explanation of the process, only one would also be fine. But here we have a double. Okay, so now we've understood. Now you have 0 bar. Really zero?
Nearly. It's very small. Maybe it's 0.001, something like that.
Okay.
But very, very low, very low vacuum. It's not 100% zero because it's not possible, but it's a very low vacuum.
Okay, so then you have a low or 0 in there, in this channel, and in this channel. Everywhere. Okay.
So then the next step, that's a very important step, and the longest step is the whole process. We have to check what is the helium background. So we create a vacuum everywhere. Then we have to check with the mass spectrometer, how the helium background, how much helium is already
inside. Okay.
Because it needs to be lower than what we want to detect afterwards.
Yes.
That's a very important step.
Okay. So you kind of like, so you know how much there is, so you have a reference point.
Yes. Then we put it on 0.
Yes. Okay.
On 0, and then we put helium in, and we can detect what is coming out.
Okay.
So this is very important step for the whole process. So then the next one is filling. For example, in the first step it's always to fill the cooling circle.
Yes.
With a mixture of helium and air. So we have 90% air, 10% helium, with a certain pressure. Usually up for the fuel cell bipolar plate, it's up to 2 bar. In most of the cases, it was around about 1.7 bar.
Yeah.
For the graphite plates, it's a little bit less, 0.7, 0.8, something like that.
Okay.
So we put the helium inside the cooling circuit first.
In the cooling circuit. Okay. Yeah.
So we fill it completely with helium.
Yeah.
Or with the helium air mixture in this case.
Okay.
Then we have our mass spectrometer, which is then opened, connected to the outside, to the chamber, to the oxygen circuit, and to the hydrogen circuit, the anode and cathode side.
Okay.
So now the mass spectrometer is looking into the chamber, into the circuits, if there's helium coming from the cooling circuit.
Okay.
There's always something coming, there's always a leak. But it depends on how big or how small.
Okay.
So that's why we have our limit leak rate.
Yeah, okay, which in
this case is, we call it 1 by 10 minus 5 millibar per liter per second.
Okay,
so 0.0001 millibar per liter per second.
Thanks for writing that out again. Okay. So 0.01 millibar by liter per second. Okay.
So this is our standard figure. And
yes.
Usually the specifications are 10 minus 4, but we have 10% helium. That's why we go down to 10 minus 5. And that is really the limit. Due to helium background, to the speed of this process, to go lower, then you need much more time, and it will be really difficult.
Okay.
So this is what we found out, the limit of this process here.
Okay.
And now the mass spectrometer here is detecting the helium atoms coming out. It's counting
if there are how much helium there is there, how much is there, and how much there.
Correct. And then we know exactly the leak rate for the outside, for the chamber, which is going out, out of the plate, and also to the other two circuits.
Okay.
And then we will repeat it for the other circuits. I haven't shown it yet, but it will be the same. We get everything out. We evacuate everything. We do the helium background check again, and then we fill the oxygen side with helium.
Okay. So coming back to the diagram, essentially, so what you did here, you put the helium in there and then check what's on the others. You then do you take the helium out of this again?
Yes.
Okay.
Everything evacuating to zero.
So you go back to 0 again
at the beginning.
Like we saw it on.
It at the first.
Exactly.
Picture. And then we do the background check again.
You do the background check again.
Again, very important because we need another new 0.
Another new 0. Understood.
And then we fill not the cooling circuit, we fill the oxygen circuit. It doesn't matter in the end.
Okay.
Then we check to the other sides.
Okay.
And then after this is done, we evacuate everything and fill the hydrogen side. So then we have 3 tests in one.
Right.
And then we have seen all the weldings, all the glued areas. If it's a graphite bipolar plate. And then we have checked the complete bipolar plate.
Okay.
Within 30 seconds.
Within 30 seconds you do all that?
The testing itself. Then we have, of course, the moving and the handling, but the test itself, round about 30, 31, 32 seconds.
Okay, so you didn't put that in. Okay, and so you detect the leak by knowing if, when the mass spectrometer finds more helium than you would want.
Then we are showing here if it's lower, 10 minus 6, for example, everything is fine. Nothing happens.
Okay.
If we are higher, 10 minus 4, for example, then it's not okay case, how we call it.
I think you brought a picture of your machine, how it does that, as far as I remember. Yes,
correct.
There we are.
Yeah. So this is our HMI, the screen of the machine. So then you can see here, this is the first part we did, the background check. So we have a certain helium background here, which is okay to test. Then you can see the helium which is in, the 12%, 10%, roundabout. Then we have the value 1, it means the cooling circuit, oxygen and hydrogen circuits. So you get, for every circuit, you get a leak rate. And as long as they are lower or smaller than you have defined it and specified it, then everything is fine. Then you get a green light. If not, there's a red light.
Okay, so here we already have several greens here. There's still
then this is not done yet.
It's not done yet. Okay, so this is how the
this is working at the moment.
Okay. Okay. Wow, that is super interesting. I have a couple of questions around that. So first of all, okay, I know you say you choose helium because it is a super light gas, just
noble gas, it's doing nothing, that's
okay, so
and very small.
And so maybe silly question, but like, why didn't you take hydrogen to test what is going to be used for hydrogen later anyway?
It would be a good idea because you run it with hydrogen.
Yes, exactly.
The problem is if you use hydrogen, to use 100% hydrogen is difficult, very difficult because of exploding areas and so on.
Okay.
Then you can use, for example, we call it forming gas. This is 95% nitrogen, 5% hydrogen. But then you have to take a much lower leak rate. So we have 10% helium, then it's only 5, so you have to go lower and lower. And to use hydrogen in a vacuum chamber is not possible today in this certain way with this leak rates. In a certain way it's possible, because you don't get this hydrogen background. It's always higher than you want to test.
Okay.
So this is where we are working at the moment. But 10 minus 4, there's maybe the limit. You can do it by sniffing, but under atmosphere level, but in the vacuum chamber, it's really difficult at the moment.
Okay, so that means
especially in these fields of leak rates.
Okay, so if you want, the reliability and everything that we need, then hydrogen is not the best thing to use to test the
Not today.
Hopefully,
the developments are getting forward, and so that we get the possibility to use it because helium is expensive. It's not endless. So hydrogen would be a good solution. But as I said, 95% nitrogen, 5% hydrogen mixture, leak rates.
So
vacuum.
As I think you said one word that I also wanted to ask you again. So in terms of expense, so I know that helium is an expensive gas. And you use it for testing. So you create the zero vacuum, then you blow it into one of the channels essentially. And then you take it out again. What happens? Do you then blow that same helium into another one? Or,
no, it's gone. Unfortunately, it's gone. That's why we use only 10%. So we have this mixture. We have the mixing unit. And there we mix it to 90% air, 10% helium. Because this 10% are gone. They are going out to the exhaust, and that's it. You can also use a recovery unit, but that's also only 90%. So in the end, it's the same result.
Okay.
So there's
So essentially that gets ejected.
10% are gone, that's unfortunately.
Just out of curiosity, that goes into the air?
Into the air, You have to bring it out of the factory hall where you have your machine. Because you don't want to
have helium everywhere.
Have helium everywhere to bring it, to influence your measurements. That's why you have to bring it outside.
Okay, so that means essentially in this process you are using a bit of helium as you go along. Okay, so everyone talks about the stacks being also like an important cost element in the whole thing. So I believe then if you are doing this as a quality assurance, this will also influence the cost. Can you tell us a little bit more on that side, the cost side, and how things are going?
So unfortunately, the machine is not the cheapest machines on the earth. It's true. We have a lot of equipment in. Vacuum pumps, 4 in total. We have the mass spectrometer, which is high in cost. And of course, the machinery around, mixing unit and everything. So there are cost for the machine at one time, and of course then wear parts like sealings and everything, and the helium consumption, of course. If you have a high capacity, a lot of parts coming out. Then
you need
and the worker in front. So that's why the next picture will show it. That's why you can use also a robot.
Okay.
Fully automated.
Can be fully automated. Okay.
Yes. Then you can of course reduce the cost for the worker.
Okay.
And that's why we also developed this machine. We built this machine. It's running since more than 1 year now.
Okay.
In Sweden, the big bipolar plate manufacturer. And we built this machine completely fully automated. And the plates are coming in here with the box. We have a vision system here, detecting or seeing the position of the plates. Robot is grabbing the plate and bring it into the machine. If they're okay, they get it out to another conveyor here. They're coming out. We can bring it to the next process step. If not, we collect them here.
Okay, so that is essentially, also in terms of an outlook, that you use obviously robotics to help. One thing I forgot to ask. So when you find a leak, what happens then?
Yeah, if you find a leak, of course you get an alarm, a notice on the screen. Yes, you have a not okay case, a red blinking one.
You know the one of the two, which one it is,
Not yet.
Not yet.
That's the problem.
We
have you know the station, yes.
Okay.
Left or right
where
station.
it happened, okay.
But you don't. Maybe you know also the channel, cooling or oxygen.
Yes.
But you don't know if it's the left or the right plate in this vacuum chamber. That's the problem if you test more than one plate at the same time.
Okay.
Then you have to do a retest. You have to put in this same tool. You have to put in a dummy. We call it dummy, just a metal plate or whatever, to have it close this side. Then to retest the two plates again. Then you know this one is okay, this one is not okay, because you can have everything. You can have both are okay, because it's always the sum of leaks. In the helium vacuum technologies, the sum of leaks. Both can be okay, both can be not okay, or only one can be not okay, the other one can be okay. So every case is possible.
So the first case is to find out which one it is. When you do find out, do you know where the leak is?
Unfortunately not.
And then, so you don't know. So what happens to that bipolar plate? Gone?
Because we are in this vacuum chamber, so you cannot see where it is. As I said, it's just the sum of leaks which you measure. So they have to find out which one of the two is it. But then they have to recycle it. Or I don't know what they are doing. I'm not.
But it gets
in this process.
Marked as.
They get it marked. Now that's not okay. We put it in the red box, for example, here. And then the manufacturer has to do something with it, whatever it is. I don't think they will throw it away because it's very expensive material and so.
They could fix it.
But you will not find where the leak is. You can sniff it, for example, then you can go over the welding seams, but very complex.
But that is probably a bit of a manual effort. You need to then repair and that's so on. Well, we have on this channel actually some videos on the manufacturing of bipolar plates, also very interesting and hell of a complex process. But I think it's really good to know now how we can leak test these ones.
That's part of the process,
and that's obviously part of the quality assurance and making sure that these things work for a very long time, isn't it?
Yeah, that's true, and hopefully for the future it will grow. So we have now sold 8 machines in total. One of them is running fully automated. I have customers who already bought the second one now, so they want to grow, to have a fully automated line for. We talk about cycle times of 3-4 seconds now. So maybe in a few years it's 1 second because they always talk about it.
3-4 seconds
cycle time. Yes.
Wow. Even though it takes 30 seconds to do the testing.
So if this machine, which you can see here with the robot, this has a cycle time of 12 seconds.
So
in total.
Wow. Okay. In total. Okay.
With coming in, coming out.
Okay.
With
12
everything.
seconds later, it
with
comes
everything.
out tested.
Wow. And then, of course, if you want to achieve 6 seconds, 4 seconds, then you need a second one, third one, because the process cannot be faster.
Okay.
Either you have lower leak rates to detect, better for us, or you only test the cooling circuit, for example, or you only test 10% of all the bipolar plates, whatever. Maybe for the future, it could be in a way not to test 100% of the plates.
Okay.
So then your quality
to use
must
statistically.
Be
Okay. Wow. But thank you, Daniel, for giving us such an outlook already. I think that
was a pleasure.
Got me all excited now. 12 second cycle time. I think. That's an announcement on time, and also an announcement at the time that we have run out of time. So unfortunately we have. But I want to thank you very much for coming and explaining this topic to us. I have learned a lot. I hope you too have watched and learned something as well. If you like it, please leave a comment. You can follow us in this channel. We appreciate that. Also, give us a message on LinkedIn or subscribe. Also, I need to tell you that you can find people like Daniel on Hyfindr with all the systems that you need all around us for the manufacturing and also later for the development of actual fuel cell systems or electrolyzer or whatever it is that you want to do in the hydrogen economy. We wish you well with it and want to thank you for taking the time to watch. And thank you, Daniel, again.
Thank you.
Have a lovely time. Thank you. Bye.
Bye-bye.